Okay, so pH. The definition of pH is a scale that shows a relative comparison of hydronium ions to hydroxide ions. The formula for pH is pH equals negative log of the hydronium concentration. Don't panic. We're going to go over it here shortly. Remember, concentration is shown in brackets. We've already learned that. No worries. And that concentration is molarity concentration. Of course, we also have molality, but we don't learn that right now. Okay, so if you have a TI or a calculator that has a log function, you're going to click the negative log and then just plug in the number. So let's look at it on the back. So calculating pH looks intense, but you're going to actually enjoy this. So calculating pH from hydronium or hydroxide. To calculate the pH, type negative log in the calculator and enter the number given. Okay? So for instance, we type the negative log, well, my calculator was on, the negative log of the number, 0.0688, and hit enter. And my pH, we're going to go 2 decimal places, is 1.16. And what is that? That is a strong acid. Okay? Now, I want us, every time we put a number in a calculator, I want us to make sure that that number makes sense. So let's look at this number in scientific notation. It would be 6.88 times 10 to the negative third. And it has a very low pH. So let's look at this number, 2.89 times 10 to the minus 10. That's a very small number. So would you expect it to have a higher or lower pH? A higher, right? Because it's going to have less hydroniums. And as we go, our pH increases, then we're going to have a higher pH. So let's check it out, see if our theory holds true. Negative log of 2.89 times 10 to the negative 10. You hit enter, and there it is, 9.54. And that is a weak base. To calculate the pH from the OH, first find the POH, which is the exact same as the pH, except looking at hydroxides, and then you're going to subtract 14. You're going to take the absolute value of this number if it's negative. No negative numbers. Okay? Absolute value, no negative numbers. So let's look at it. We're going to take the negative log of 7.15 e to the negative 12th, hit enter. Subtract 14 and take the absolute value of that, which is 2.85. So our pH is 2.85. Let's see if that makes sense. Okay, so I have a very small amount of hydroxides. Well, we know that acids have a small amount of hydroxides, so that's good, right? And so this is going to be a strong acid. Let's look at this number. Do I have a large number of hydroxides or a smaller number of hydroxides? Look at, yeah, larger, because this is only to the minus 3 versus the minus 12. So since I have a larger number of hydroxides, I expect my pH to do what? Increase or decrease? Increase, right? So let's check it. We have 3.47 e to the negative third. Oops, I forgot to do the negative log. Negative log of 3.47 e to the negative third. I'm going to subtract 14 from it, and I get 11.54. Because this number right here is the POH, and I'm looking for the pH. And our pH plus POH equals 14. Okay, because our pH scale goes to what? 14. And our POH is on the base side. And I want to look at the pH. Okay, so you guys are going to practice here. I'm going to come back to that. Right now I'm going to skip down and we're going to review naming and writing formulas and neutralization, and then I'll be done. Okay. Okay, so naming acids. If the hydrogen is with an element, we're going to add hydro to it. Don't do that, baby. We're going to add hydro prefix to the name of the element. And change the ending to ic. If hydrogen is with a polyatomic ion, do not add hydro. You're going to name that polyatomic ion and change the ending. If it ended in ate, it becomes ic. If it ended in ite, it now becomes OUS, and we add the word acid afterwards. Remember that? Polyatomic ion. So we have SO4. SO4 is sulfate. 8 becomes ic. But we got to add the sulfur ending back to it. So this becomes sulfuric acid. Okay, HCl. Cl. What is Cl? Chlorine. It's just an element, so it says add hydro to the name of the element. So this is hydrochloric acid. Good. And now we have Br. So what is the name of that compound? Good. Hydrobromic acid. Se. Okay. Selenium. So this would be hydroselenic acid. PO4, that's a polyatomic ion, phosphate. So this is phosphate. 8 becomes ic, and we got to add the OR back from phosphor. So it will be phosphoric acid, just like we had to do with sulfuric. Last but not least on these examples, NO2. This is nitrite. Ite becomes OUS for nitrous acid. Okay, so we're going to go through here and we're going to look at monoprotic, diprotic, and triprotic. The hardest part of chemistry right here. Protic means proton or a hydrogen. How many is a mono? 1. Which one of these have just one hydrogen? Hydrochloric acid. What's next? Hydrobromic acid. What's next? And nitrous acid. Diprotic. How many is a di? 2. Which compounds in here have 2 hydrogens? Good. H2SE, hydroselenic acid, and H2SO4, sulfuric acid. Triprotic. I was being sarcastic, right? So tri is 3. Which one has 3 hydrogens? Phosphoric acid. Good. All right, I have just 5 minutes for the video left, so we're going to move right along to if the writing formulas. If the name starts with hydro, we use the periodic table to find the element. Okay, so let's look at the Hill method. We have 1A, 2A, 3A, 4A, 5A, 6A, 7A, plus 1, plus 2, plus 3, plus or minus 4, if it's a metal or not, minus 3, minus 2, and minus 1. Okay, so we're going to find, we use the periodic table to find the element and the charge. Because remember, when we're writing formulas, we have to swap and drop like on ionic compounds. So we swap and drop. I know you are all so excited. Okay, so if the name does not start with hydro, we look at our polyatomic ion list. Okay? We're going to look at the ending of the first name to decide which polyatomic. If it ended in if it ended in ic, it becomes 8. And if it ended in OUS, it was ITE, just the opposite of what we wrote up here. So we have hydrochloric. So hydro tells me what? To use the periodic table, it's just the element. Hydrogen is a +1. Chlorine is a -1 because it's in group 7A. So we swap and drop and get HCl. Nitric acid, ic, becomes 8. So our polyatomic is nitrate, NO3 -1. Hydrogen's a +1. We swap and drop and we get, good, HNO3. Chlorous acid, OUS, tells me that my polyatomic was chlorite. So H +1 and then ClO2 -1. Swap and drop and we get HClO2. Sulfurous, OUS, becomes, ITE, thank you, sorry. So we have H +1 and SO3 -2. Swap and drop and we get 2SO3. Okay? All right, going back to January, we've been all over the school year. We came back to October. Now in November, now we're at neutralization from types of reactions. The reaction between an acid and a base is called a neutralization reaction. The two products are a salt, which remember is an ionic compound, and water. Yes, I'm going fast. I only have a minute left. Because heat is released, this type of reaction is classified as exothermic. The process of adding a known amount of a solution of known concentration to determine the concentration of another solution is called titration. Okay, check your answers, please. Guys, be quiet. So we have, for our practice problems, remember to subtract 14. For this one, we do not, because it's the hydronium concentration, we do not subtract 14. For this one, we don't subtract 14. And then the hydroxide concentration, we do subtract 14.